Welcome to week 5. This is a pretty busy week with plenty of Blackboard content providing how-to on numerous calculations. Let me click on the anthropometrics folder. This explores how to calculate a number of different things: ideal body weight, percent of ideal body weight, percent of weight change, adjusted body weight, and there are also several YouTubes demonstrating these calculations. All right, energy, protein, and fluid needs are determined by an individual's age, height, weight, and medical conditions. So we take all of those things into consideration. You need to learn how to convert to metrics, and over time, I would encourage you to memorize the Mifflin-St. Jean formula. On our exams, I will give you that formula, but the NDTR credentialing exam will expect you to know that. Of course, that's after graduation, so you have some time to get that formula wrapped around your brain. All right, and protein calculations, well, let's just look down through here for a moment. So in these metric conversions, you're taking someone's height and dividing it by 2.2 pounds to give you the metric equivalent in kilograms. For height, you're going to take their height in inches and multiply that by 2.54, and that will give you their height in centimeters. All right, so you'll see some other formulas here. We used to use this Harris-Benedict formula faithfully. This was the gold standard, but things have changed a bit now. In addition to calculating the formulas, you must add a physical activity factor. So unless I'm specifically telling you to include an injury or stress factor, you just are adding this physical activity factor. So we consider the formula calculation straight up as the BEE, or basal energy expenditure calculation. And then you multiply that by an activity factor. Typically, we're only using, I don't see it on here, but 0.8 for just some resting, gentle activity. By the way, BEE is just our energy expenditure as we sit and breathe. But we don't just sit and breathe, we do other things, and so we need to account for that by some physical activity factor. So a patient who may be confined to bed, 1.2 is their physical activity factor. For light activity, we might use just 1.1. And so as you begin to practice these in the summer practicum and on down the road, you get a sense of experience as to what particular levels you are going to use. But for our purposes, you need some guideline getting started. For sports and heavy activity, you might be using 1.5 or greater, 2.0, and so on. We also give you some stress factors here. For surgical issues, you'll learn about those next summer. Again, we are probably not going to use much of this stress factor business this semester. So we just want to hone in on the PA, or the physical activity. So you come up with the BEE from your formula, you multiply it by an activity factor. Usually this is going to be light activity, 1.1, could be even a little less. Okay. And so I'm going to scroll through here. Here's our Mifflin-St. Jean. There is a calculation for men and for women. slightly different, and then a few other calculating. So I'm going to scroll a moment back up here quickly. Apologize for that. Let me get into, let's see, what do I want to look at? Oh, I want to mention about the protein calculations. Generally, when you're calculating here, you're going to be coming up with protein needs by first determining the kilogram of body weight and then multiplying that by one of these stress factors. And so I know I just said we weren't going to be using stress factors, but for protein, you do need, to do this equation. So generally, we're going to be using 0.8 as our basis. It could be 1.0, but generally we're sticking to these lower levels. And so then that gives you the grams of protein. All right, and then let me go into, this is not scrolling for me. Let me go back one. Let's get to fluid. So in fluid, you are again calculating the weight into kilograms times one of the following, and then converting that sum into common terms, meaning into cups. Okay, so we convert their weight into kilograms, and then we multiply by 25 milliliters of water, or 30 or 35. Generally, I would stick with 30 if someone is real small or they're elderly, 25. If they are overweight or obese, I also probably would not use 35. I would stick to 30. Okay. And then once we multiply that weight in kilograms by 30 or whatever factor we're using here, we come up with a total number of milliliters. And of course, that's a term that we're rather unfamiliar with. So now we need to put that into something common or familiar to us. So to convert this 2,454 milliliters into cups, we divide that by 240, and that 240 milliliters equals 1 cup, or 8 ounces, and the end result is that we have 10.2 cups. So we have milliliters for detailed medical information and data, and then we convert it into something else that's friendly to us or to a patient if we're explaining what their fluid needs are. All right. In the nutrition care process, which we revisit this week as well, we come to the signs and symptoms of that PES statement. And so I'm going to just read this example so you understand what I'm talking about. So this PES statement right here, excessive energy intake, meaning they're consuming excessive calories. That's our problem. And that's related to very low energy expenditure that is insufficient for managing appropriate weight and excessive caloric intake, All right, and that's specific verbiage from our problem list and our etiology list. And then our signs and symptoms, this is all as evidenced by BMI percentile of greater than the 95th percentile for age and height. This is related to measurements for children. It's how they express BMI for kids. Okay, so there are not specific verbiage for the signs and symptoms because you need to pull data to include there. What you're observing, what convinces you that this problem and this etiology have occurred, and you sum it up with those signs and symptoms. It supports the problem and the etiology. All right. In the assignment, you are challenged with using many of these formulas. So let me click into our assignments quickly. Okay, over here. All right, and so let me pull this up for easier seeing here. So what we have are 3 patients, and you're going to be calculating their ideal body weight, their percent of ideal body weight. All of the information you need is right here in the left-hand column. And then for patient 1 and 2, you're going to use the Mifflin-St. Jean equation to calculate their total energy expenditure. Remember, that's BEE times a physical activity factor. And then you're going to calculate their fluid requirements, also converting the final answer into that common form of cup measurement, and including their protein measurements. Okay, and then for patient number 3, you're calculating their data to find their adjusted body weight. And then once you find the adjusted body weight, you'll be able to calculate the Mifflin-St. Jean formula. Show that all so that I can see that you're understanding the process. And check your math. All right, and then you're calculating protein and fluid requirements using the adjusted body weight. And you'll need to convert those into kilograms. All right, one thing I do want to mention is that your formula calculations will be off if you do not calculate the correct height. So remember that a male who is 6 foot 3 inches is actually 72 inches for the 6 foot, plus this person is 3 inches over that. So they're actually 75 inches tall. So be very careful about, think through some of those calculations. All right, you are to show your work, which benefits you because you can get partial points for having part of the equation correct, even if your answer is not. Also, the final answer again should be in TEE, not BEE. On Thursday of this week, checkpoint number 2 becomes available and is only open through next Tuesday night. So I make a mental note about that. Be sure to get that checkpoint done within the window of time. Another reminder, our second Zoom meeting is next Tuesday evening to practice interview techniques, and we'll talk at length about the nutrient analysis projects. There are several projects tucked into this one big project, I guess I should say. I guess I should have said those were several assignments that are tucked into this big project. All right, I encourage you to get a head start on the chapter content for next week to prepare for a Go React video recording that is due next Saturday. Have a great week.